Machine forging. It is a process wherein a machine forging is also the material is deformed by squeezing into the shape of dies in the machine. But here the squeezing action happens in the horizontal direction. This type of forging involves only the upsetting operation and hence it is called as upsetting forging. In an upsetting machine, a set of dies and a punch or heading tool are used to carry out the forging operation. The die consists of a stationary part and a movable part. The whole workpiece is held in position between the two dies. The upset forging operation starts with a movable die sliding towards a fixed die to grip the workpiece. When the two dies are in close position, the required shape of cavity will be formed and the workpiece is in position as in the figure. Now the punch moves forward to squeeze and upset the material to fill the die cavity. After completing this, the punch moves back and the movable part of die release the forged component. The machine forging process is suitable for mass production of components like nuts, bolts, axles, gear blankets, etc. The process gives better quality for forging and better productivity compared to drop forging. But the tooling cost is higher and is not suitable for complex and heavy jobs.
Open die forging. In open die forging, a solid cylindrical workpiece is placed between two flat dies and compressed to reduce the height and deform it laterally. This process is known as upsetting. In open die forging, the metal is not completely confined as it is undergoing forging process. Consider a block of rectangular cross section as shown in the figure undergoing open die forging. In the figure, workpiece is placed in the center and the dies are placed on both sides of the workpiece. Under the ideal condition, the workpiece gets deformed as in the figure B. Due to friction between the die and workpiece surface, the workpiece deforms into a barrel shape as in the figure C. Barreling can be minimized by the use of lubricants or by the use of heated dies. Most of the open die forgings are produced using flat dies or platens. Round swedges and V dies are also used in pairs or with a flat die for open die forging. There are four types of dies shown in the figure: flat dies, V dies, flat die and V die, swedge dies. The basic forging operations carried out by the open die forging methods are upsetting, fullering, edging, drawing. Advantages of open die forgings are simple to operate, favorable grain flow and metallurgical structure, suitable for low volume of production. Equipment and tooling are inexpensive, wide range of workpiece. There are limitations for open die forging, suitable for simple shapes only. Closer tolerance are difficult to obtain. Moderately skilled workers needed. Further finishing is needed for products.
Impression die fogging. What is impression die fogging? As you may know, fogging uses compressive forces to shape billet metal into more complex forms. In the case of impression die fogging, two or more dies are used to shape a metal will that's been heated to the proper temperature dependent on the component's design. Fogging may require one set of dies or a multi-stage process with many sets of dies. With multi-stages fogging, a part can move through bursting, blocking and finishing dies. The first two stages helps form the part's initial construction, while the finishing dies fine tune geometrical details without significantly changes the item's shape or increasing material flow. How does the impression die fogging process work? Impression die fogging, also known as closed die fogging, because each dice set behave a little like a pair of casting molds. This process uses a hammer along with the manufacturing dice, with the typically connected to an anvil. When the hammer is dropped once on the workpiece, the hot metal flows and occupies the dice cavities. The hammer may only touch the workpiece for a few milliseconds at the time and may be rapidly dropped several times in a row. Any leftover hot metals that's pushed out the dice cavities is called flash. Since it cools down more quickly than the metal inside the die, it blocks more hot metal from escaping and turning into more flashes. This also ensures that the remaining hot metal fills up the die. Once this fogging process is complete, the flash is taken away and the finished product is left behind. Impression die fogging process operations. In the simplest example of impression die fogging, two dies are brought together and the workpiece undergo plastic deformation until its enlarged sides touch the side walls of the die. Then a small amount of the metal brings to flow outside the die impression forming flash that is gradually thinned. The flash cools rapidly and present increased resistance to deforming and helps build up pressure inside the bulk of the workpiece. The adds metal flow into unfilled impressions. Unsetting. Fundamentally, impression die fogging produces on horizontal fogging machines. Upsetters are similar to those products by hammer or presses. Each is the result of forcing metal into cavities in die with which separate at parts lines. The impression in the ram operated heating tool is the equivalent of a hammer or press top die. The grip dies contain the impression corresponding to the hammer or press bottom die. Grip dies consist of a stationary die and a moving die which, when closed, act to grip the stock and hold it in position for fogging after each work stroke of the machine. This dice permits the transforms of stock from one cavity to another in a multi-impression die. What benefits does this fogging method offer? Closed die fogging is very effective for shaping aluminum, steel, titanium, and a wide range of the metal alloys. By enclosing the hot metal inside sets of dies, many kits of the three-dimensional shapes can be produced. This includes simple forms such as cubes, discs, and spheres, but it can also be applied to multi-section parts that incorporate thin, delicate webs and long, spindly shapes. Impression die fogging is also useful for parts with holes, pockets, and protrusions, and even asymmetrical part can be produced through the process. Thanks to the fogging process, high quality components can be manufactured at a relative responsible cost. The resulting part resists both fatigue and impact, are very durable, and have higher strength to weight ratios. Sometimes these parts are up to 20% stronger than those produced by other fogging method. Closed die fogging also generates less waste metal, and this refined method is capable of higher production rather than other techniques. Who uses impression die fogging? This fogging technique is used in many manufacturing applications. You will commonly find out die fogging part in the automotive industries as well as the railroad, mining, aircraft, aerospace, and defense industries. Tool companies are also some of the most frequently using thanks to the strength and reliability reliability of impression die fogging items. What is drop hammering fogging? What is drop hammer fogging? The manufacturing industry plays a major role in the national economy. It also literally creates as well as maintains modern lifestyles through the components it produces. These items are not just end products such as clothing or athletic shoes you shop for at the mall. This industry also makes specialized tools that makes fabricated and end products possible. Manufacturers have developed various methods to make particular items. One on this process is called drop hammer fogging. The drop fogging process ultimately helps makes your life more comfortable and convenient. Technique base Technique basics. Heated metal is placed onto the lower die. The ram brings the other die down, delivering a set number of blows to shape the hot metal. The number of blows needs various depends upon the item being manufactured. Fog, the drop fogging process is aptly named, and while it sounds simple, a great deal of power is involved. In some cases, the upper hammer on the ram may be dropped using the force of gravity alone. However, it is also common for mechanical forces to be applied to move the hammer. Some hammers can drop with a pressure of 50,000 pounds. At tension fogging, we use this technique to produce components for numerous industries, including the product produ- including the aerospace, automotive, agricultural, and material handling sections. What is drop hammering fogging? Simply put, it is a fabrication method. It is a fabrication method employing two dies, one on a stationary anvil and the other attached to a moving ram. Advantages of drop hammering fogging: no wastage material, strong part with good mechanical properties, fast production method. The drop hammer process also make it possible to align metal grains along with potential stress locations, which improves overall strength. The components we make using this process are generally stronger and work for longer in high stress conditions, making this process a valuable operational aspect of the manufacturing industry.
Flashless forging. It is true closed die forging in which metal deformed in a die cavity permits virtually no access metal to escape. During this process, the preform is totally enclosed in the die cavity so that no flash is formed. In actual practice, fin or ring of flash may form in the clearance between the upper punch and die. This can be easily removed by blasting and doesn't require a trim die. This process carried out in an elevated temperature, which in between cold and hot forging. Workpieces are heated only to the level at which the metal flows just enough. under forging pressure to fill the die, but not so freely as to extrude from closing die halves before the cavities are filled. This process is usually accomplished in one or two processes. Benefits from flashless forging over closed die forging. Material waste. In closed die forging, operation flash averages 15 to 30% of original workpiece, but flashless forging uses 100% of stock. Energy waste. Heating metal that will become flash, transporting it, and then deforming it expends energy for no useful purpose. Production time. Flash formation creates undesirable internal structures in forging. Better control of grain flow is achieved in flashless forging as it eliminates the grain flow that lies at 90 degrees to the free surface as in closed die forging. Flash trimming operation and equipment used in flash forging also again adds up cost and production time. Advantages: material and energy saving, no deflashing operation, reduction of subsequent machining work through smaller machining allowances and as a result of lower tolerances of blank material, higher dimensional accuracy, higher production rate, higher strength and integrity as internal grain structure flow of metal within the part, produced part are in net shape. Disadvantages: high tooling cost due to complex die shape, requirement of high volume accuracy of blank and thus an increased demand in blank production. The process requires a careful mass distribution. Flashless forging process need more careful die design, particularly for non-symmetrical part in comparison to
Precision forging. Precision forging normally means close to final form or close tolerance forging. It is not a special technology but some refinement of existing techniques to a point where the forged part can be used with little or subsequent machining. Without the subsequent machining, the forged part can be used. Precision forging have the basic same working principle. The simple difference is that the precision forging has higher requirement on the surface, also similarly on the dimensional tolerance and also on the shape. The precision forging usually need very less machining or in severe cases without machining it can also be done. As a process of a one-time forming, precision forging needs precision size, weight and shape on forging blanks. As mentioned earlier, there is no flash in precision forging, so according to the design processes, material will be forged into desired shape after plastic deformation. So in that case, some parts will require only a small amount of machining after forging, and some can be put into use directly, which from which we can conclude that no machining will be required, as it can be put into use directly. Its application are several. To name a few, such as the railway industries, and the industries include other industries like mining industries and agricultural machinery parts and automotive industries machinery parts and everything. Here, the precision forging is used in all these cases. Its advantages includes good working performance, high utilization of material. Also, the precision forging has allowed the production of more complicated shapes. With the use of this method, we can produce the very high complicated shapes. It can be done with atmospheric temperature or semi-high temperature. From this, we can understand that the temperature will not be a limiting factor because high temperature is not needed. But in this method, high temperature is not needed, which is in the case with other techniques. And the only disadvantage is its cost. It's not as cost effective as others, although when compared with others it's not very cost effective. So the only disadvantage of precision forging is its cost.